Alright guys, welcome to Pre-algebra 5.6. We're talking about using multiplicative inverses to solve equations. What? What is a multiplicative inverse? What? That's easy. You know what? Multiplicative inverse is the reciprocal of a number. So you've already used it. We just call it the multiplicative inverse when we're using it to multiply in an equation or using it to solve an equation. Just like this. Okay, so the second item would be like if we had 4/7 times x equals negative 1/12. Well, we have a variable, we have an equal sign, it's an equation. What do we do with equations? We solve them. So the problem here is that x is not by itself, right? As is the problem on most equations. We want x to, of course, be by himself and equal to some number. So 4/7 is being multiplied by x. So naturally, if something's being multiplied by x, we do the inverse, right? And divide. But we can't divide by a fraction, right? It would not be correct to say, let's divide by 4/7. That just looks crazy because you have division with division and division and division and division, and you don't want to do that. So how do we solve an equation that has a fraction like that? Well, we use, again, the multiplicative inverse or the reciprocal. The reciprocal of what, though? Well, remember, the goal is to get x by itself. So here's what we're going to do. In order to get rid of that 4/7, I'm going to multiply by its inverse, which would be 7/4. So I'm going to multiply that whole thing right there by 7/4. But if I multiply one side of the equation by 7/4, I need to multiply the other side of the equation by 7/4. Now, I am multiplying an integer by a fraction. So I'm going to multiply this negative 12 times 7/4. And I'm going to set it up like this, which looks a little strange. But what is the reason? What do you think? Well, remember, in order to multiply, I got to multiply a fraction by another fraction. So I need to make this negative 12 into a negative 12 over 1, right? I didn't really change anything there. I just put the denominator of 1 there so that way I can multiply across the top, across the bottom. Anyway, let's work on this side first. 7/4 times 4/7 x. Well, this is actually simpler than it looks. Let's just do a little recap. If I gave you 4 times 2x, what would you say? Well, you'd say that's like saying 4 times, because remember parentheses means multiply, times 2x, which is really like saying 2 times x. And 4 times 2 is 8. We'd have the times x, and we could just write 8 times x as 8x. So we're really doing the same thing here. 7/4 times 4/7 x could be rewritten like this. 4 over 7. And 4/7 x is like saying 4/7 times x. And what do we see here? Well, we have something multiplied by its reciprocal. That just becomes what? Well, a 1 times that x. Okay, so these two multiplied by each other became the 1 because they're reciprocal. So when you multiply them, they equal 1 times x. And 1 times x is like saying 1x, which is really just like saying plain old x, right? Okay, so let's work on the other side here. Negative 12 over 1 times 7/4. Can I simplify this fraction? No. Can I simplify this fraction? No. Can I cross cancel? Yes. I have a 4 here and a negative 12 there. How do I cross cancel? Divide them both by the same thing. I can divide them both by 4. So if I divide 4 by 4, it becomes 1. If I divide negative 4 by 4, it becomes negative 3. So let's multiply across the top now. Negative 3 times 7 is negative 21. And 1 times 1 is, of course, 1. So negative 21 over 1 is really like saying negative 21. And there is your answer. X is equal to negative 21. All we had to do was multiply both sides by the reciprocal. Alright, so why don't you pause the video, try this one, play it when you're done, see what you get. Alright, so we have an equation. Why? Well, we have a variable and we have an equal sign. So we need to get that variable by itself, and it's an x, so let's get the x by itself. What is the problem? Well, the x is being multiplied by 4/5 x. That's what 4/5 x means. It means 4/5 times x. So how do we get rid of multiplication? Well, we use division. But what's the problem? The problem is we can't divide by a fraction. Or at least we could do, tell you what, we'll do it this way. We know we have to divide by 4/5, and that's not the correct way of setting it up, but we know what? Well, we know that we have a 4/5 multiplied by the x, and we got to divide that by another 4/5. But what's the proper way to do that? Well, the proper way to do that is keep, change, and flip. And so if we do that, those cancel, become ones. Those cancel, become ones. 1 times 1 is 1. On top, on bottom, 1 times 1 is also 1, and that just equals 1. So we're really left with 1x equals, well, I have to divide this side by 4/5 as well. So 100 divided by 4/5, remember I need to make that into 100 over 1. And so I'm going to keep, change, and flip. And let's see, I can cross cancel. It becomes a 1, it becomes a 25 if I divide both of them by 4. And 25 times 5 is 125 over 1 times 1 is 1. Our answer is 125. So 1x equals 125, otherwise known as x equals 125. Now that is one of the ways you can do it, but that's not the way we've been learning in this video. So let me go back to kind of what I taught you and why I think it's a little bit easier to use the multiplicative inverse. I think it's a little bit neater. Right? If you use the multiplicative inverse, you're essentially doing the same stuff you're doing here, right? But I think it's neater. So let's do this. We're going to multiply by the inverse of 4/5, which is 5/4. Okay? But we have to do the same thing on the other side. And remember that 100 has to become 100 over 1. Now, we could draw out the 5/4 times 4/5 times x thing for here. But what do we know? Well, we're multiplying by the inverse, the multiplicative inverse, so that this guy goes away or becomes 1. So here's what I do. I know that if I draw it out and do the long multiplication, 5/4 times 4/5 is going to equal 1. I just go like this. Cancel them both, and it leaves me with x. All right, that's the shortcut there. And that's going to equal, okay, well, we're going to do the same canceling that we did, over here. We're going to do that same thing over here, right? So let's see, 104. If I divide both of them by 4, that becomes a 1. That becomes 25. Multiply across the top. 25 times 5 is 125 over 1 times 1. I don't really need that 125 over 1, so I'm just going to leave it as plain old 125. And there you go. Alright, so maybe that's too easy for you and like, okay, whatever. Well, let's try this one. How about 4/9 x plus a 7 equals 31? Why don't you solve that? Well, what will we do? Well, why don't you pause it, try it, just do whatever you think you need to do to solve that, and then play it and then see if you did it correct. Well, what do we have going on here? Well, we have an equation. Why? Because we have an equal sign and we've got a variable, so we've got to solve this equation. We want it to be x equals something in the very end, right? So, why is x not by itself? Well, there's two reasons. One, he's being multiplied by a 4/9. The other reason is there's a plus 7. So, in solving equations, do I deal with the plus 7 first or the times the 4/9? Remember, I do the opposite of order of operations. I'm going to deal with the adding before I deal with the multiplication. How do I deal with the plus 7 or add 7? Well, I do the inverse of add 7, which is subtract 7. But if I do it from one side, got to subtract on the other side. So I'm left with 4/9 x plus 7 minus 7 cancel or become 0. And that equals, let's see, 31 minus 7 should be 24. Okay? So 4/9 x equals 24. How do I solve this the rest of the way? Well, remember 4/9 is being multiplied by x, so I got to do the inverse, which is divide. But remember, I really shouldn't do one of those things like that, divide a fraction by a fraction like that. So what do? We use the multiplicative inverse. The what? The multiplicative inverse. Wait, what? Multiplicative inverse, what's that? Remember, it's just the reciprocal. So I'm going to multiply by the reciprocal of 4/9, which is 9/4. But if I do that to one side, got to do it to the other side, and on this side I'm going to make that 24 over 1. Multiply. What happens here? What happens here? Remember, we know that they are just going to cancel or become 1 and leave you with just plain old x. That's going to equal, let's see, can I cross cancel anything here? Well, actually, before I cross cancel, oh, I put that over 2. Why did I do that? That should be a 1. 24 over 1. I don't know what I'm doing. Anyway, can I cross cancel? Yeah. 24 over 4, I can, well, let's see. If I divide both those by 4, that becomes a 1. That becomes a 6. Can't cross cancel anything else. Let's multiply across the top. 6 times 9 is what? Well, 6 times 9 is 54. Over 1 times 1, which is just 1. 54 over 1 is just the same as saying 54, and there is your answer. X equals 54. Alright guys, that is all I have for you in this video. Hope you liked it. And remember, we are talking about the multiplicative inverse, otherwise known as the what? Reciprocal. We just call it the multiplicative inverse when we use it to solve equations. And I will see you guys in class.